Welcome to Physics Prep. This is the second in a series of questions that we will be doing from different competitive exams in physics. These competitive exams can be attempted after completing one's graduation. The present question is taken up from JEST 2019. In the question, we are told to find the rate of change of current in a circuit with a DC voltage source and has the components of resistor and an inductor. To solve this question, we should first be aware of the behavior of a resistor in a DC circuit and that of an inductor in a DC circuit. To that end, we'll first analyze the behavior of resistor in a DC circuit. To analyze the behavior of a resistor, we'll first require a circuit. This is our DC source to which we connect a resistor. Let's get a key here and close it. Now we have a closed circuit. Let's take any point, any 2 points. Let's call them A and B and draw and actually put a voltmeter across them. Let's call it Vx. Now Vx will be the difference between the voltages at A and B, and since our current will move in this direction, we will do Vx equals to Va minus Vb. Since this is only a wire, the potential here will be V, and here again it will be the same V. So Va and Vb can be both substituted by the source voltage, and this will give us 0. If we do the exact same thing across a resistor, let's call them points P and Q and join a voltmeter here, V of R. Then V of R will be the voltage at Q minus the voltage at P. Now what we find is that there is a certain potential drop on the resistor. Okay, the voltage at Q is lesser than voltage at P by IR. Now that is how a resistor affects the potential in a circuit. Now we can move on to analyzing the behavior of inductor in a DC circuit. Let's first get our DC source and we'll connect an inductor to it. Let's get a key here and the circuit is completed. Now inductor has a more strange behavior than resistor, since if you have an inductor and you have a current going on here, but the current is not steady but changing with time, say di by dt is not equals to 0, which means the current changes with time, then what happens is the inductor creates a magnetic field due to Faraday's law, and that's why creates a back EMF which opposes the direction of current. Now that back EMF, let's call it V of H, equals to minus L di by dt. The negative sign comes because the direction of the voltage or the potential is in the opposite direction of the current. That is why we have got Vh equals to minus L change of current with time, rate of change of current. But one may wonder, how come there be a change of current with time in a DC, with a DC source? Because the very definition of DC is that the current and the voltage remain constant with time. This is the current axis. Then the current usually remains constant with time in a DC circuit. However, in the beginning of a DC circuit, what must happen is that the current should go from 0 to attain a constant value. And that is where the inductor can create a back EMF. So we do have Vh equals to minus L di by dt, at least in the transient phase of current, even though it is not present in the steady phase of current. Now we have looked at the behaviors of the components resistor and inductor in the circuit, so we can begin to solve the question. First, let's make the circuit. This is our voltage source, let's call it V, and we have said that we have a resistor, let's call it R, and it is in parallel with the inductor. Okay. Now this is our circuit, and let's call the inductor H. Okay. Now we already know that the potential at R is minus of current times the resistance, and the potential at the inductor is due to back EMF, which is negative of inductance times the rate of change of current. And the rate of change of current also appears in the question. So that is our value of interest. Now we are given the voltage, the resistance, the inductance, and we have equations. Let's call this 1 and let's call this 2, which relate our numbers to our value of interest. So we need to find a law, rule, or something that we can use. And here comes Kirchhoff's voltage law, which says that the potential of each component in a loop adds up to 0. And in our case, that will be the potential due to battery at the resistor and at the inductor adds up to 0. And we'll replace the quantities from equation 1 and 2 here. We'll have a minus sign here. IR minus L times di by dt equals 0. And that is L times di by dt equals to minus V plus IR di by dt equals V minus IR by L. All of these values are already given in the question. Voltage is given 80, current we need to find at 12 amperes, resistance was 5 ohms, and inductance was 20 Henry. So this gives us 1 ampere per second. So back to our question, and our answer will be option B.